here we have to find the transformation equations to rotate axes through an appropriate angle to eliminate the xy term in the equation. So we have to find transformation equations using these rules here. So as you can see, this gives you the old coordinates in the original axes in terms of the new coordinates. And these coordinates are representing the new system, okay, the new axis system. So we have to find the, first of all, the angle of rotation, and then we're going to use that angle, and if it's impossible to find that angle, we're going to have to work it out somehow to still find these equations, right? Because as you can see, we have to have the cosine of theta, the sine of theta, in order to derive in order to represent the old system coordinates in terms of the new system coordinates. So sometimes even if you don't know the angle, you can still find cosine of theta and sine of theta. But in this case, we have to try to find the theta. If we can't, we're going to have to use trigonometric identities to derive the values for the cosine theta and sine theta. So in this case, first, let's compare, just like the previous video suggested, we have to compare the A and the C coefficients, right? So in this case, A is 16. C in this case is 9, right? And we know A is not equal to C because 16 is not equal to 9. So therefore, we have to use the equation tan of 2 theta is equal to the B value, and the B value is the 24, right? The coefficient of the xy term. So the B divided by, so 24 divided by A minus C, right? So 16 minus 9. And if you're unsure how I got that, please watch the previous video. I explained the rules for finding the angle theta, all right? So first we compare the A and C. If A and C are not equal, then we use this equation. Tangent of 2 theta is equal to B divided by A minus C. If the A and C are equal, then the tangent, we don't use the tangent. The theta is automatically assumed to be 45 degrees. In this case, it's not, right? So we have to use this equation because A and C are not equal. So as a result, this is what we get. This is equal to 24 divided by 7. Notice now the problem is we don't know, we can't find the arctangent of this and get the precise value for angle theta. We cannot solve for it. We don't know the precise value, right? If you use your calculator, it's going to give you a decimal answer. It will be about 36, 37 degrees, but it's not going to give us exact answer. So what we can do, we have to set 0 is less than twice theta is less than 90 degrees. Why? Because the tangent here is positive, and we know that the tangent of 2 theta is positive in the first quadrant of the unit circle. The first quadrant is having this constraint from 0 to 90 degrees. Okay? It's going to be positive between 0 and 90 degrees in the unit circle. Right? So we're talking about the input 2 theta is between 0 and 90. Now, how do we work around this? How do we actually find the value of the cosine theta and sine theta needed for the transformations to derive the equation of representing the old system coordinates in terms of the new system coordinates? How do we do that? So the way to find the cosine theta and sine theta is to realize that the secant 2 theta, so notice I'm not talking about theta with the coefficient 1 so far. We're still dealing with the twice theta. Right, still dealing with a double angle, right? But we're going to find that, right? So we know that secant of 2 theta can be represented as square root. Notice I'm using this fine identity, 1 plus tangent squared of 2 theta, right? I'm using the identity secant squared 2 theta is equal to 1 plus tangent squared of 2 theta. So if you take the square root, you will get secant of 2 theta, and you will take the square root on the right side. That's why I have the square root here, 1 plus tangent squared of 2 theta. So as a result, this is equal to 1 plus, now we know that tangent of 2 theta is equal to this. So squaring it means we have to square this fraction, right? Which is equal to 576 divided by 49, right? Squaring the 24 and squaring the 7 gives us that, right? And then we get what? We get 49 divided by 49 plus 576 divided by 49. So what this gets us to is 625 divided by 49. Notice the good news is both of these are perfect squares. 625 is a perfect square, and so is 49. 625 square rooting it gives us 25. Square root of 49 is 7, right? So that's good news. So secant of 2 theta is 25 over 7. Now, what we're going to do is we realize that the cosine of 2 theta is going to be the reciprocal, right? Because we know the cosine is reciprocal of the secant, right? So 1 over secant of 2 theta. Now, the good news, we found the secant of 2 theta to be 25 over 7. Reciprocating, it means that you're simply switching the 7 and 25, right? So 7 goes on top, 25 goes on the bottom, right? So the cosine of 2 theta is 7 over 25. So that's good. Now, we know that the angle theta will be between 0 and 45. How do I know that? I basically divide both sides. I basically divide all three sides by 2. Right? If I do that, I realize that the angle theta will be between 0 and 45 degrees. Okay, so it's going to be 0 and 45 degrees. So thus, and it makes sense, right? Because I said to you, if you solve for if you solve for 2 theta, if you solve for theta by hand and use your calculator, you will get something like between 36 and 37, right? And that makes sense because 36 or 37 is between the 0 and 45 degrees. But in this case, we're going to use the following identity. So sine of theta is going to be this: 1 minus cosine of 2 theta divided by 2. All right? And both sine theta and cosine theta will use the cosine of 2 theta. And we found the cosine of 2 theta to be 7 over 25. Right? So this is equal to 1 minus 7 over 25 divided by 2. Okay, so this is equal to 25 over 25, 25 over 25, minus 7 over 25 divided by 2, which is equal to, let's see, 25 minus 7 is 18. 18 over 50. Let's see, so this is 18 over 2 times 25. Well, actually, let me put that down as 9 because that would be easier, right? So that would be 9 over 25. So this is equal to 3/5. Okay? So that's the sine of theta. So let me circle that. Sine of theta is equal to 3/5. So now the cosine of theta is similar identity, except there will be a plus and not the minus, right? So 1 plus cosine of 2 theta divided by 2. So what that gives us is 1 plus 7 over 25 divided by 2. So that should be 25 over 25 plus 7 over 25 divided by 2. Right, so that should be 32. 32, and let me do 32 divided by 2 first. That would be 16. So 16 over 25 should be your resulting fraction. And good news is both of them are perfect squares, like in the first case. So this is 4/5. All right. So basically, try to see. You can solve for angle theta if you want, if you're curious. Notice that we don't really need to find the angle theta to use these transformation equations, right? Because they're given in terms of cosine and sine that we found, right? So we can go directly into finding the old coordinates in terms of the new coordinate system. all right? But if you want to experiment, you can use your calculator and take and solve for this theta by taking the arc cosine of 4/5, or by finding the same theta by using the arc sine of 3/5. And that will give you the same answer between 36 and 37. I think 37.8 or 9 something, right? Something like that. It's going to be a long decimal answer. So in this case, we can go ahead and find these equations. So what we need is x is equal to 4/5. Now, how did I get 4/5? I'm getting 4/5 from the cosine of theta, right? Let me actually circle that so you can be sure you find it easily. So 4/5 is the cosine here for the x coordinate, for the old x coordinate. And then x prime, right, will be multiplied to it, the new x coordinate, minus, now sine of theta is 3/5. So we can put 3/5 y prime. And that's it. And then the y, the old y coordinate, is equal to sine of theta this time. So it's going to be 3/5 x prime plus cosine is 4/5, right? So 4/5 y prime. And to put it in a simpler form, what I would do it like this. X is equal to, notice that in these two terms, the 5 is the common denominator. So we can put it as 4x prime minus 3y prime divided by 5, right? Because 5 is the common denominator to these two terms in these fractions. And the same thing for the y. So the y is equal to 3x prime plus 4y prime divided by 5. So these are your respective coordinates or coordinate equations of transformation when it comes to the rotation of the axes to eliminate the xy term in the given equation. So I hope this was useful and fun. Thanks for watching. See you in the next video.